In today's lesson, we're going to look at identifying attributes of 3D figures or identifying figures based on their attributes. So I'm going to start by making sure we understand what we're talking about when I say attributes. There are three key elements to three-dimensional figures that we will be using as those attributes. So I'm going to start with what I have here. It's a cube. The first attribute that I'm going to mention is what we refer to as a face. So like this space here, this entire surface of the cube, we would refer to as a face. And we define a face as a flat surface or a surface that could be made flat. And that'll make more sense when we get over here. So I have my face. Erase that. Another attribute that we may be discussing, or we will be discussing, is an edge. Defining an edge as where two faces meet. So for instance, this edge here is where this face and the face that's currently my base come together. The final element we need to define is this part right here, which you will hear referred to as a vertex, multiple being vertices. And a vertex is where two or more edges meet. Or you can kind of think of it as a corner. So I've got vertex here, 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 and so on. Some of these elements are also present in this figure, which is a cylinder. So for this figure, I have faces, face here, face here. And then for our purposes, the outside curved surface, we're also going to refer to as a face. So that's where I said earlier, a face is a flat surface or a surface that could be made flat. If I think of this as a toilet paper roll, for instance, I could slice along this edge and open it up to lay it flat. Because of that, we are also going to refer to the curved outside element as a face. This cylinder also has edges. I have two faces that meet here, so I have an edge. And I have two faces that meet here, so I have an edge. A cylinder does not have any vertices. There is no point where multiple edges are coming together. There is no corner per se. So no vertices on my cylinder. So with this knowledge, face, edge, and vertex, we're going to look at different figures and define the number of faces, vertices, and edges that these figures have. The first thing that I want you to do is name the figures. So I want you to pause the video, look at the figure that I have here. You're welcome to zoom in on the screen if the image is small on your screen. And we need to give names to each of these 3D figures. Resume the video when you are ready to check that part. On my screen, you can see how I have labeled each of these figures. I'll read them just because it's written using my digital pen, and so it may be difficult to read. This first one is a cube. Here I have a triangular pyramid. This is a rectangular pyramid. If you said square pyramid, that's fine as well. I have a triangular prism here. This is a rectangular prism. A cylinder, a cone, and a sphere. So if you mislabeled any of these, make sure that you correct those before we move on to the next step. where we're going to be identifying the number of faces, vertices, and edges for each of these figures. If you are doing this from home and you are struggling, I recommend finding as many of these as you can around your house. Now, some of these may be a little bit more difficult. You may not have a triangular pyramid or rectangular pyramid just sitting around, but I suspect that you should be able to find a cylinder, a cube, a rectangular prism, possibly a cone if you have a party hat or a funnel, a sphere you may have laying around the house. So gather as many of these as you can find and use them as you are trying to identify the number of faces, vertices, and edges, the physical element in front of you. Go ahead and pause the video at this point, list out number of faces, vertices, and edges, and resume when you are ready to check. Here are the accurate results for all of these. I want to mention a couple. For a cone, when I say that there are two faces, the first face is the base, that circular base at the bottom, and the second face is the cone part itself, the piece that wraps around the top. I have one vertex on this, that's that point at the top, and the edge is where my two faces meet. So that's where this is coming from. For a sphere, for our purposes, this has one curved surface or face. If I were to cut a sphere open, in theory, I could lay that flat. And so for our purposes, a sphere has one face, but it does not have any edges or vertices. So make sure that you have this information listed somewhere, that you understand how to find this information. And as always, if you are confused about any of these pieces, make sure that you communicate that, ask questions before proceeding.